Thanks. I will present the genetic evaluation of the textile breed in Uruguay for carcass and meat quality traits. In this study also participated Chapiazzoni, San Julián, Navajas, Jimeno, Gutierrez Amit, and Brito. So as a consequence of the increased consumer emphasis on meat quality, sheep breeders and sheep breeding companies are more interested on meat quality traits and the possibility for implementing these traits into breeding programs. In sheep, very few studies have reported genetic parameters for lamb carcass and meat quality traits, and in general, these difficult-to-measure traits have received less attention despite their economical relevance, particularly in extensive environments in which sheep production is mainly located. Talking about the genetic evaluation of textile breed in Uruguay, we have that due to the relevance of growth, carcass, and meat quality traits as breeding objectives of textile as sire terminal breed in Uruguay, a genetic evaluation system was implemented since 2008. The traits recorded are birth weight, weaning weight, scanning weight, that is the live weight at the time of the ultrasound scanning, ribeye area, and fat thickness. And as a fundamental component of the genetic evaluation, a central progeny testing was established in the stud flock Laripuca, located in Cerro Largo, at 300 kilometers from Montevideo. And the main goals of the central progeny testing are to facilitate the genetic linkage between the stud flocks and to allow the genetic evaluation of carcass and meat quality traits. So the objective of the present study is to obtain estimations of the genetic parameters and breeding values for in vivo and postmortem carcass and meat quality traits of textile breed raised on grazing conditions. The material and methods, carcass and meat quality data were recorded on 424 female and male lambs from the central progeny testing, which were slaughtered between 2009 and 2013, with an average live weight of 38.9 kilograms and a body condition score of 3.5. And pedigree data comprises 982 animals, including 23 sires and 318 dams. And in vivo carcass traits were 3,109 records from 9 stud flocks, including the central progeny testing, and the pedigree data include the same amount of animals. So the traits we measure were divided in vivo and post-mortem traits. The in vivo carcass traits were the scanning weight, ribeye area, and fat thickness that are routinely evaluated in the genetic evaluation system of this breed, with an average age of 255 days. And post-mortem traits were divided in the carcass trait and meat quality traits. About the carcass trait were hot carcass weight, tissue depth as GR, as a fatness carcass, as an indicator of fatness carcass fatness, weight of the most valuable cuts, French rack, shoulder with bone and boneless leg. And the morphometric traits were carcass length, and leg circumference. And the meat quality traits were the color parameters, L as relative lightness, A relative redness, and B the relative yellowness. The terness measured as the Warner-Brasler shear force, intramuscular fat content, and fatty acid profiles, the percentage of saturated, monounsaturated, and polyunsaturated fatty acids. The statistical analysis for heritabilities were estimated by univariate analysis performed with the GIBS 2F90 computer package. Multivariate analysis were carried out for in vivo traits. The animal model included the year flock, birth type, sex, dam age, and the age at slaughter as fixed effects. The estimated progeny difference were estimated using the Blue F90 software. We also calculated the correlations between EPDs of the different traits for lambs with postmortem records that were 424, And finally, association between the main CPDs of RAM used in the central progeny testing, that were 23, were plotted. So to present the main results, in this table we have the descriptive statistics for in vivo and postmortem carcass traits, with the number of records, the mean, the standard deviation, minimum and maximum value of each of one. The scanning age had an average age of 259 days, and the slotted age 292. And then we have the descriptive statistic for the in vivo and postmortem carcass traits. In the next table, we have the descriptive statistic for the mid-quality traits, for the color parameters, the Warner-Brasler shear force, intramuscular fat, and the fatty acid profile. So, about the genetic parameters, the heritabilities and genetic correlation for in vivo carcass trait are in the next table. In vivo carcass traits that are routinely recorded showed moderate heritabilities values and a higher genetic correlation between them. The postmortem carcass quality traits have moderate to high heritability values, indicating there is a scope for genetic improvement in these traits. However, these preliminary values should be interpreted with caution because of the small number of animal recorded. The estimate of heritabilities for the mid-quality traits were low to moderate, in the range of 0.12 and 0.27. And the Pearson correlation coefficients between the EPs of animals with post-mortem records, this is for carcass traits, were all the correlations positive and favorable. The exception could be the correlations with fat thickness and GR, depending on the selection objective. For instance, we know that increasing the scanning weight and ribeye area by selection will cause a correlated increase in these fatness traits, but could be favorable, neutral, or unfavorable, depending on the current phenotypic levels of carcass fat of pure and crossbreed lambs, as well as the production system and the market specifications. The hot carcass weight EPD presented high correlation coefficients with the valuable cat EPDs, rack, shoulder, and leg, and the cat weight also presented high correlations with ribeye area EPD. Here in these figures are plotted the associations between EPDs of the main traits for rams used in the central progeny testing. We have here the association between ram hot carcass weight EPD with scanning weight, with rack area, with fat thickness, with French rack weight, and with leg weight EPD. So although traits are correlated, the magnitude of the correlation allows selecting for multiple objectives, even when correlation could be considered unfavorable. In this table are presented the Pearson correlation coefficients between EPDs of animals with post-mortem records, but for mid-quality traits. Some of the correlation were not statistically significant, but we have some interesting results. For instance, the scanning weight and ribeye area showed a moderate and positive correlation with color parameters, indicating that the selection for heavier and more masculine carcass will increase color parameters, being lightness and redness the most relevant for consumer acceptability. The correlation between the ribeye area and intramuscular fat was negative and moderately. So this value is in concordance with the evidence that extreme selection for masculine or fatness had an unfavorable effect on meat quality. Other results, the correlation between intramuscular fat and fat thickness GR were positive, so increasing total content of fat carcass by selection on in vivo or post-mortem criteria will lead to high levels of intramuscular fat. Intramuscular fat was negatively correlated with Warner-Brasler shear force, so higher intramuscular fat is linked to better turness. And finally, the correlation between the intramuscular fat with the fatty acid profiles. We had a negative correlation between intramuscular fat and polyunsaturated acids, so decreasing intramuscular fat would increase the proportion of the healthier fatty acids. So the conclusion of the present study, in order to improve the carcass weight and quality traits, the currently published EPD could be used due to the positive correlation between EPDs of in vivo and postmortem traits. Although there is a general trend of reducing the meat fat, the evaluated lambs in this study did not present a high degree of fatness, probably due to the leanness of the breed and management. This emphasizes the relevance of evaluating the selection objectives, taking into account the difference between production and crossbreeding system and the demands from global or niche markets. This preliminary estimate of the genetic parameters suggests that there is sufficient genetic variation for genetic improvement of lamb carcass and meat quality traits by selection. Furthermore, the estimate of the genetic correlation provided very useful insight of some antagonistic associations. And even being of moderate magnitude, there is scope for obtaining favorable genetic progress by the identification of suitable selection criteria and the implementation of appropriate selection index. So our next step are the publication of carcass traits EPDs, the hot carcass weight EPD, rack and leg in the next genetic evaluation of the Texel breed in September of the present year. And we are trying to develop a terminal selection index. Thanks.